Aber soll ich mal spielen?
All right, now I'm host, I think. Share screen. Okay, yeah, I can share my screen. Okay, take two. Sorry about that. Like I said, this is a whole new topic, super excited. We're doing code generation back in Python. Hopefully this will be mind-blowing. I think that's everything I said earlier. So, all right, I will share my screen. And okay, so yeah, like I said, we're doing code generation today. And so let's see. This is just a quick outline of what we're going to do. So let's just jump right in. What is code generation? Does anybody want to offer a definition of code generation? Anybody? There's something in the chat here. Let's see. When you make code with code. Yeah. So, I mean, yeah, that's pretty much it. And that's why I asked this question, is because it's almost a silly question. You know, what is code generation? Well, it's when you make code. So it's printing code, basically. It's when you output code. Printing is how you output, and so when you print code, that's code generation. And that's it. Next slide. How do you print code? Anybody want to offer how to print code? Control P. So I'll offer how I think I would probably print code. I would call print on a string. That's code. So that is basically code generation. So that's it. That begs the question, though, like how do you make a string of code? Like if we're going to print a string that's code, how do we make that string of code? Well, you just write regular code and you wrap it in quotes, right? If that's how you write code, you know, we write code by just writing code. And if you want to write a string that's code, you just put quotes around it, and then you can print it out, and boom, you've just done code generation. Okay. So, okay, now we really know what code generation is. But let's talk about quotes some more, because it's not really so simple as just putting your code in quotes, obviously. I mean, code generation is a topic, so if it were that easy, there wouldn't be a lecture on it. So let's talk about quotes. First of all, strings are not .py files. The things that we can write in a .py file are not the same things that we can write in a string. And we can prove it to ourselves here. If we print this, does anybody know what's going to happen?
It's going to print hello world.
You use double quotes for both the inside and the outside, so it'll error.
Yeah. We wish it would print hello world, but actually this quote here matches with this quote here, and Python thinks that that's the end of this string. And so this doesn't actually compile. It's a compile error, invalid syntax. So the way we can fix this problem is by escaping out the inner quotes. So if we want to tell Python, hey, look, I know there's a quote here, but don't treat it like the end of the string. Treat it like a quote in the string. We put a backslash before it, and then it knows, oh, okay, we actually mean to print out this. But I mean, this is the very first example of how typing out code in a string is not the same as typing out code in a file. I mean, if you were just typing out print hello world in a file, in a .py file, we wouldn't need this backslash, obviously. And so this is an example. I mean, already we're getting into kind of trickier code generation than you might think. Python's really nice in that it has double quotes and single quotes, and so if you use different quote types, Python recognizes that. So I'll be doing a lot of that this lecture. Does everybody see how that isn't a problem? Python knows to match the double quote with the double quote, and the single quote doesn't end the double quoted string. So we're safe here. This prints hello world. So yeah, we've already seen escaping quotes, line breaks, tabs, and spaces. it might seem like this is all kind of trivial stuff, but it's actually way more important than you might think. Escaping is actually kind of tricky. And if you want to prove it to yourself, go and look up SQL injection. I'm sure anybody in cybersecurity or defense maybe has probably looked at SQL injection. You have to be careful with how you escape strings. You can get into all sorts of trouble when you have a string that represents code, and inside of it, a string that's supposed to represent data, but maybe that data actually looks like code. You quickly start getting into really tricky territory. Was there a question? Or was that just a mic slip up? Any questions so far? Okay. So usually, often, we want to generate code that is dynamic in some way, that responds to some input to the runtime, not just a constant string. So here's an example of that. We're going to print input. So we're going to print out some code that will print what the user inputs. Is that what this is going to do, or does anybody have a different idea of what this is going to do? What we want to do is get some user input and print out some code that will print that user input. But that's not what this will do, because we didn't do any magic here. This is still just a string. So it's not like we called input here. We just put it in the string, and so this will print input. That's not really what we really want. We really wanted to construct a string that represents some code where what gets printed was the input. So you see how these two things are different? This actually calls input as part of the code generation step. And then if we input, let's say, max, this will generate code that prints max. So we have to be careful about where we put what step so that we're actually computing what we want before we put the string together, not after we put the string together, because then it's too late. Okay. Here we did this with concatenation. We got the string that we wanted to print out, and then we concatenated it with some print and some parentheses and some quotes. And string concatenation should be pretty much familiar to everyone here. You just have a string and you add it to another string and it puts the two strings together. So now that we have the power to generate code dynamically based on some runtime, what is the first thing that any metaprogramming savant might want to do with that power? Maybe somebody in 2150 or who's taken 2150?
Quine?
Yeah, a quine. What's a quine?
It's a program that will print itself.
Yeah, a quine is a program that prints its own source code, that outputs its own source code. And now that we have the power to output code, to generate code, the most meta thing we could do now is some quines, I think. So let's do some quines. So here's a line of Python. And it's hard to tell what's going on here because it's just so mind-blowing. Quines are very hard to wrap your head around. We're creating a variable called self, and it's a string. And then everything in here is in that string. And it just so happens that this string is print self equals plus self plus quote new line eval self. So, okay, cool. That's just a string. And it looks kind of like the line of code that we're writing, but not completely. Like the string itself can't exactly match the line of code that the string is defined on because the definition of the string is outside of the string. So we can't match it completely. But what we can do is evaluate that string. So it turns out evaluating that string, well, what did we write here in the string? Well, we wrote a print statement that prints this string plus itself, plus the string itself, and then eval self. So the trick here is that we're using eval to both execute and concatenate a string at the same time. We're using concatenation and execution at the same time in order to do a quine. Now this doesn't work. Does anybody see why it doesn't work? I mean, it's in the error statement, but it's kind of hard to map the error statement back to the original quine attempt here. Why didn't this work? Anybody know? It's tricky. I mean, we get this end of line while scanning string literal. So what happened here? We called eval on this string, and we expected this string to be some Python code that we could evaluate. Well, let's look at this string. There's a new line right here. That actually breaks this evaluation statement. You can't have this string. You can't, I mean, inside of this string, we have an inner string, but this inner string is broken up by a new line. That doesn't compile. If you were to just, let's say, open a Python shell and put quote, hello, enter, world, quote, that wouldn't work. You can't have a new line inside of a single quoted string. So eval fails here because this inner string has a new line in it. The fix for this is going to be to make it so that that new line is not part of the outer string, it's part of the inner string. Really what we want to happen here is for this new line to print out this new line, the new line in the code that we're writing right now. We had to put a new line between the self definition and the eval and the call to eval. We need a new line to come before eval. But we need it to come after calling eval, not in the construction of the original string itself. So to do that, we need to escape the new line. So here we're going to put another backslash here. This is going to say, okay, don't treat this new line character as a new line in this string. Treat it as a new line character in the string that is inside of the string that we wrote down here. I mean, we've got this, the string contains this inner string, and we want that inner string to have the new line, so we need to escape the new line character once. So here we are escaping escape characters so that we can both concatenate and evaluate a string of Python code at the same time. And it almost worked. Any questions up until here? Because I know I just said like many long sentences. Okay, so we got pretty close here. What's the problem? And we can tell it doesn't quite match up because this line is longer than this line. It's the quotes here. I mean, when we defined this self variable here, we had to put quotes around the outer string. But here, when it got printed out, it didn't get printed out with quotes. And that's because evaluating this print statement prints a string, but printing a string doesn't put quotes around it by default. Printing a string will just print the string. And specifically, it's this string right here, self. It's the string that we're concatenating. That's what will end up here in the output. This part of the output is self. It's what we're concatenating to ourselves. And so we need this to show up in quotes. It turns out that Python has a very convenient way of doing this. When you print something, it calls str on it. It casts it into a string. And when printing a string does not include quotes around it. But calling repr on something will get its representation as a string. And it turns out that the standard for implementing a repr is that you should be able to evaluate that code as Python. You should be able to evaluate the string as Python, and that it should end up evaluating to the thing that you called repr on in the first place. So what that means for strings is that if you call repr on a string, it'll give you the string with quotes around it as a string. So it turns out all we need to do to fix this is we call repr on self inside the string, again, because this is all just a string. But when we evaluate that string now, we're going to call repr on self, and that'll get self, but with quotes around it. so that when we print it out, now we get exactly the same thing. It's okay if you don't totally wrap your head around this. I'll be totally honest. I barely wrap my head around this. I mean, I'm looking at this code now and I'm like, wait, what did I write again? It's really weird. But the trick boils down to having a string that's both code and data. Strings are data. This string happens to be code. And we concatenate it to itself while executing it. And that's where the magic happens. And later on, it's going to become convenient to write quines on one line. And to put multiple Python commands on a single line, we just use a semicolon. So here's the same quine, but with a semicolon. And this also gets rid of the new line problem. Questions about this? How easy is it to add something to this quine? What do you mean by add something to this quine?
I guess just like if you wanted to print something else out with like if you wanted to add anything to the output, or it's just some arbitrary change to the program, like another line of code.
Like you wanted like a quine, but that also adds two numbers or something.
Yeah.
I think it wouldn't be too hard. Yeah, I don't think it would be too hard. That being said, off the top of my head, I couldn't tell you exactly how to do it. I mean, you would have more lines of code, and then you would have to represent those lines of code in the string in some way without duplicating them. You'd probably have to do some more eval tricks, but it's definitely possible. Yeah. Okay. So that code got kind of hard to read with all the nested pluses and the, concatenation within evaluation. There's a better way to do this. It turns out it's a very common thing to have to insert values into a string. The more appropriate way to do this is usually with something called string.format or string formatting. And if you're used to C or C++, especially C, you're probably used to this because when you call printf, you use format strings in order to insert values. That's what we're going to do here in Python. So if we print out this string, but then call .format on it and pass in some stuff into format, whatever we pass into format is going to be inserted into the string wherever we had curly brackets. So like these curly brackets, these denote to the string formatter that something should be filled in here, and then we're passing what that thing is here. So now if we run this code and input max, then we get print max. And this is nice because we can basically do concatenation by just chaining format strings. So we have curly bracket, dot format, and then we pass in two things, the input and maybe an exclamation point. Maybe this is also variable at runtime or something, we don't know. Now when we input max, we get an exclamation point at the end. So we're basically doing string concatenation, but this is nicer because you can tell at a glance that these two things are going to end up next to each other, and you can see their context much more concisely. When you're concatenating strings together, you have lots of quotes all over the place and pluses, and it's very hard to tell exactly what closes what at the end of the day. This is much nicer. You can also use keyword args here. So if you have a lot of these things, then it gets kind of tricky to remember the position of them. Here you can also reuse them. So if we wanted to reuse the name in this format string, we could reuse it and we wouldn't have to pass it in again. Questions about format strings? str.format? Okay, so we just did quines with concatenation. Let's try to do a quine with format. Can anybody guess what, so before when we did concatenation and eval, the trick to doing the quine was both concatenating and evaluating the string at the same time. Can anybody guess what the trick is going to be here? How are we going to make a quine with string formatting? To me, it's basically the first meta thing that I can think of with string formatting. I mean, if you were to ask me, now we have this power to have format strings and call .format on them and pass values in to fill in the string. What happens if you call .format on a string but pass in itself? Can you format a string on itself? Well, it turns out you totally can. So that's what we're going to do. Here, similarly, we're making a string, and this string starts the way that the line starts. And we're going to set it set self equal to some format. This exclamation R, that's what calls repr. So it turns out inside of a format escapement, you can put exclamation point and a special character that will denote what method to use to convert the string. So here we're saying use the repr method, please. Semicolon, print self.format self. Semicolon, print self.format self. So what are we doing? We're taking this string and we're formatting it on itself. So this part will stay the same. All we're doing here is inserting this string in here. And it turns out that is all you need to do a quine with format. The trick is just to format the format string on itself. So with quines, very often it's almost a competition to try to come up with the shortest possible quine. So let's try to do that here. There's a couple easy ways to make this shorter. Basically, we just take out all the empty space and change self to S. And you can see already we're getting a pretty short quine. But it turns out we can get even shorter by taking advantage of a different way of doing formatting. And this isn't hugely important. It's almost deprecated. I mean, it's still a feature of Python, but not very many people use it anymore. But there is a binary operator, the percent sign that we usually think of as mod, will actually do string formatting. And so we can replace this .format with %. And then the way that you do the format escapement is a little bit different. So here is that. And it turns out this is, as far as I know, the shortest quine in Python. So now, if you look up shortest Python quine, and you see this jumbled mess, you'll know what's going on. The percent sign basically means format. The double percent sign is a way of escaping the format string, because percent sign inside the string is also the way of denoting where the string will get formatted. So this percent %R is where the string will be inserted into itself. And then the double percent here is just an escapement of what we're ultimately executing right here. Quick note, like I said, if you look up the shortest Python quine, this is probably what you'll see. If you go to the Geeks for Geeks article on quine in Python, it shows almost this, but there's a problem. It doesn't work. It's wrong. And so I left a comment, and this was like one of my first contributions to Geeks for Geeks. So feel free to go check me out, upvote my comment, because it's wrong. It's just straight up wrong. It does not print itself. And then there were other problems with the article too. So just disclaimer, be wary of what you read. Always execute it to see if it actually does what you think it does. Questions about this? I think this might be our last quine for the day. Okay. So writing all these quines, I found it really convenient to write a quine checker. Because how do you tell if something's a quine? You have to execute it. That's kind of a hassle. You have to check if the string matches completely. There were a couple times where I thought I had written a quine, but I actually had missed a small change in the string. So I wrote myself a quine checker. And I just want to show this because it might be useful in part 2 of the homework that's starting now. This homework that's starting now is a 2-parter. And for part 2, this might be useful. So check quine. We take in a string. We want to see if that string is a quine. We're going to have to execute that string, and we want to capture what it outputted. So we use this output context manager. And then we execute the string. We restrict its globals and locals to nothing, so that it's not like it gets to take advantage and hack us or anything. It's just a empty Python environment. We need to wrap this in try-catch, because if the string that was inputted is not just not a quine, but also doesn't work, then we want to gracefully exit. Otherwise, we get the result of what the string executed and printed. And if the result is equal to the string, then we've got a quine. If it's not, then we don't. So nothing too crazy here. There's actually no code generation here, but it's just an example of how exec and code generation can go really well together. When you're generating code, often it's nice to be executing it too. So reflection, code generation, all interrelated. Questions about this? Okay. You might notice here, I did something a little weird, and I've been doing this throughout the slides, and maybe some of you have noticed and some maybe haven't. But what did I print here? I printed out this string, but I used these kind of format notation, these escapements here, and I passed in this string result, but I didn't call .format. I didn't pass in a string or a result. So where are these coming from? Turns out Python has this amazing feature. I think it started in Python 3.7. And just for reference, this entire lecture is based on 3.8 until the end. Here, if you put an F before the string, that tells Python to basically call .format on this string whenever we need to evaluate it. So here we're printing it. We need to evaluate the string. Python will call .format on us, for us. And where does it get the string and result value from? Well, it just gets it from whatever variables are accessible. So this result and this string just automatically get formatted into the string. We don't have to say .format result equals result, string equals string. I mean, obviously that's verbose, because then we'd be saying string result 3-4 times. The F string allows us to just basically insert values in place from the environment without duplicating any code. It's really nice. So here we can see an example of x is 1. We just evaluate F string where the curly brackets evaluate x, then we get 1. Turns out in Python 3.8 they added this cool thing where you can put an equal sign at the end, and that will not just print out what x evaluates to, but it'll preface it with what you're printing. So this will actually print out x equals 1, which is so great for debugging, because you always add a print statement where you print out the value, right? Oh, I wonder what the reference count is here. You print out reference count. But then you do that a couple times and you lose track of what all the outputs are. It's like just 1, 10, 0, null. What are those things? Well, if you do it this way, you just tack on an equals sign and it'll print out exactly what you're printing and what it evaluated to. Super nice. And it turns out that what you put inside of these curly brackets can be any Python code that evaluates. So we can put x plus 1 equals, and that will print out x plus 1 equals 2. So really nice stuff, very handy. Okay, so we've got this new method of doing string formatting. Let's dig into it a little bit. This is the code we had from before. Can we nest them? I mean, that's what I think when I see, oh, we've got format strings and you can put any valid Python code inside of the curly brackets. What if we put a format string inside of a format string? So let's just try it. Let's just try it out. We're going to do this. And similarly to before, we're going to use the different quotes in order to just be safe here. We're going to format the string containing the format of 1 plus 1. And it turns out, yep, sure enough, 2. It worked. So we can nest format strings. How far do you guys think this can go? Like, how many format strings do you think you can nest? Anybody want to take a bet?
Like infinite.
Infinite? I mean, that would be, I would definitely believe it if you said that.
As much as your stack allows.
Sorry? What was that?
As much as your stack allows until you get.
As much as the stack allows. So infinite with the limitations of the hardware, 200. Yeah, that's what I would think too. And for all I know, you guys might be right. But we need to take a look here at what we're doing. We're using the quote difference in order to keep things straight here. And if we try to use backslashes to escape, it turns out that actually doesn't work, because you're not allowed to backslash inside of the curly brackets. That gets just too ambiguous. Python doesn't know how to deal with that. Is this an escapement on the level of the string outside, or is this an escapement on the level of the string inside? It gets very ambiguous pretty quick. So we're not allowed to do it. So that means the only way we have right now to actually differentiate between the two format strings is different quotes. So you might think that it's just, you can only nest them twice. But yeah, somebody has just pointed out in the chat, you can nest them 4 times because you can use triple quotes. As far as I know, this is as nested as a format string as you can make. Is that a limitation? Probably not, because probably if you find yourself doing this, you're doing something wrong, because this is crazy. But it's kind of interesting. It's a food for thought. You know, there appears to be a hard limit on the number of nested format strings you can make. All right, here's another question. Can we quine it? So before we had the power to call .format on a string, and we passed in the string that we're formatting with itself. We formatted the string with itself, and we were able to make a quine. Can we do that here with f strings? I don't think so, because the f string gets formatted as soon as it's evaluated. The trick with the .format call explicitly was that we could delay the formatting of the string until we had defined it, and then we were able to use it on itself. But here, because the format string gets formatted as soon as it's evaluated, we can't defer that formatting. We can't use the code both as data and as code. So I think you can't quine these, at least not like how we did before. I mean, for all I know, there is a way, but I couldn't find one. Okay. So you might be thinking, like, obviously this is crazy. I mean, these nested format strings don't do anything for us. I mean, we could have just written this as just a single format string. So why might this be useful? Here's an example. Let's say we wanted to take this list of strings, A, B, and C, and we wanted to print out a parenthesized, comma-separated list of the values parenthesized. So we want to take A in parentheses, comma, B in parentheses, comma, C in parentheses, all in parentheses. How would we construct that string? Well, you could do it with some loops maybe, or some string concatenation, fancy stuff. But I think this is probably the shortest way to do it, easy to implement. We have a format string that puts the parentheses on the outside of the entire expression. So we're formatting parentheses, parentheses, and then we're executing some Python code in the middle that will get inserted, that will get formatted in. And what's that Python code? We're going to do comma.join, and then a format string where we put parentheses on the inside things. So if we evaluate this, we get what we wanted. So this is an example of why you might want to nest format strings. Now I've introduced something here that I've used in other lectures, but I haven't talked explicitly about, is this string.join method. String.join is a great way of combining an undefined number of things into a string. So we're using format and concatenation to combine a restricted number of strings, but what if we want to concatenate an entire list? Well, that might be a great usage of empty string.join. That will take this list and concatenate them all together, no matter how many there are. And we can also do it with things like plus, like maybe we want to take in space-separated things and then add them all together. So string.join, format strings, technically none of this is metaprogramming because it's just building strings. But as you can see here, look at these strings we've built, parenthesized expressions, comma separated, a bunch of numbers added together. these are features that are really useful if you want to do code generation, because often you find yourself wanting to combine multiple things and you don't know how many of them there will be. Or you find yourself wanting to insert many values, but also with parentheses to make sure that everything checks out, that kind of thing. So these are all features that aid in code generation. And f-strings and string.join go really well together. Let's see an example. I'm going to resurrect an example from the attribute access descriptors lecture. So you might remember we made this descriptor person. The details here aren't that important, but our goal was to automatically generate an init function, and we did that by using a meta class that took all the fields and then constructed this crazy string that was the init function, and then we executed that string on the fly and then created the class. And what this did was it made it so that when you define the class, it automatically constructs the string and executes it as if we had written it, even though we didn't. So this is an example of code generation where we're not outputting the code that's generated, we're executing the code that's generated on the fly. It's cool stuff, but it's really hard to read. I mean, it's hard to tell exactly what we're actually building here. I mean, we're doing this comma separating and these format strings. What is this doing there? You know, what is this? So it turns out there's better ways. And we're going to look at two of them. The first way is to put more work into the string that's being formatted. So we're going to have a more complex template processor, a more complex .format step. And we're going to put the complexity in the string itself. So let's take a look. We've got the same code as before. We've got our meta class, we get the fields. But now instead of constructing that crazy string with .join and .format, we're going to make a template of an init function, like a prototypical init function. So here it is, from Jinja 2. This is a library called Jinja. We're going to make a template, and we're going to put in it def init, because that's how all init functions start, self, because we have to take in self. And then we're going to do this thing here. We were using curly brackets before to insert Python code that we wanted to evaluate and then insert into the string. Here we're doing something different. What is this? We're like writing a for loop inside the string. We're getting all the fields, and then we're going to use more curly brackets to evaluate that f as if it were Python code. And we're going to end the for loop, end the method header, and then write the body of the method. So what's going on here? Basically, before, when we had to concatenate that variable number of things, we did it with string.join. And that took any number of strings and concatenated them or comma separated them. Here what we're doing is we're doing that work in the string itself. We've made our template represent the any number of, the concatenation of a variable number of things. The template is representing that. The upside is that it's very easy to tell that this is a prototypical init function, and every field is going to end up showing up here and here and here. Now, if you've used Django, I'm sure this syntax looks familiar to you. Turns out Jinja is based on Django's template engine. And so that's a great example of code generation. If you've ever written a Django template, you're generating code, you're generating HTML. HTML is code. And so templates are a great way of doing that, very readable. If you had to construct your HTML files in Django by calling string.join and f-strings, what a nightmare that would be. I mean, that would be, you would have like huge blocks of HTML in your Python files. Here, we can export it into just one big string, and it turns out that Jinja supports putting this string in a separate file. So we could call this like, you know, init function.py.template. And then the template would load in that file. And then the way that we actually format this string with the data is we call .render. So we take our template and we say .render. We pass in the data that we want accessible, and then that will do everything we want. So now if we make a class that uses this meta class, you can see we print out the code, and the code that gets printed is this. And one annoying side effect of all this is that putting in these for loops and this extra information in the string sometimes results in kind of crazy white space. Like, we've actually, you can see here in the string that got printed out, there's an extra new line between every parameter. So ultimately, what's happening here is we're deciding to make the trade-off between the readability of the template and the readability of the generated code. Here, the generated code gets executed immediately, so it doesn't really matter that it's readable. However, it does matter that the template is readable, because that's what we're actually going to be spending our time fixing, looking at, enhancing, understanding. So templates are a great way to shift the readability to where it actually matters us, the code writers. Questions about Jinja template rendering? Could also apply an auto formatter. Yeah, we talked about auto formatters last week with code compile time computation. Yeah, absolutely. If the readability of this code, the generated code, did matter, we could write yet more metaprograms to fix that. And that would probably be the right way to do that, actually, because auto formatters are good. Okay, so this was one way to improve upon the format join method. We put more work in the template, more work in the formatted string. The other way to improve upon it is to put more work in the code, basically go the opposite direction. So in this next example, we're actually not going to see any format, or almost any format. And the example here is going to be javapoet. This might be useful with the homework again, because I modeled this homework after an old homework that used to be in Java, and then I switched it to Python because nobody wanted to do the Java homework. So I figured I'd get more people doing it if it were in Python. But this was my example that I gave last year, and it had to do with code generation. First thing we do is we get what should be printed, and then we're going to generate code that prints that thing. So we're going to try to generate code that prints answer. And here with javapoet, the way that we do it is we don't use a template, we don't use format or join, we use method builder. And we call the method main. We can add modifiers, public, static, we can say what it returns, we can add parameters, add a statement. Here is the one place where we will see format here is that within javapoet, within this object-oriented interface for generating code, you can still use string formatting if you want. And so the string formatting, we build this method, and then we're going to build a type, because all Java files have to have a type. We're going to call it test, and we're going to add a public, add the main method, and we're going to add a Java doc. And then at the end of the day, we're going to actually output that file. So this is code generation, but here, we didn't really do any kind of templating, formatting, any string manipulation. We let javapoet, this library, do all of the work for us. And just so you know, this design pattern is called a fluent interface. So this pattern of chaining method calls to build up a complicated object is called fluent interface. One benefit of this is that we'll be guaranteed that this code will compile. When we generate the string ourselves on the fly, we might make a mistake, just like how we might make a mistake writing a regular program. But here, this will make sure that the curly brackets always match. We will never forget a curly bracket with this method. It will make sure that everything checks out. This is very common for SQL generation. You see this a lot in SQL generation. So the other example I have of this kind of style is the Django query builder. So again, if you've used Django, this should look very familiar. You see things like this: users equals user objects dot filter, and then maybe we only want the users whose first name is Max. And then we'll filter again. We only want the users whose boss ID is in, again, the user objects, but where we exclude maybe the inactive users or something. And then we can dot execute that. It turns out what's happening under the hood here, in Django at least, is that all of this data is being stored in a SQL database. And so, constructing this complicated .objects.filter nestedness what's actually being generated here is a SQL query, and then when we hit .execute, it'll actually go and run that SQL query for us. So there's actually code generation being done in the background here. You just don't see it because it's hidden behind this interface that also happens to match with what we want as the program writer. So code generation can crop up in all sorts of unexpected places. Okay, so there's one final method I want to talk about, and I'm running out of time, so I'll do it quickly, and that is tree-based. You might know, or you might not, because you haven't taken theory of computation or compilers, but code is represented as a tree under the hood, a syntax tree. So the last way we're going to do code generation is by manipulating and taking advantage of that tree. So here's an example here. We've got some code in the bottom right corner, and if you call ast.parse, this is a Python library in Python, you can call it on a string of Python code, and you'll get a representation of that code, but as a tree. So here we can see the tree. We've got a module and a function definition, which takes an args and an if statement with a return value and an assignment. This is a tree that represents that code. And so we're going to take advantage of this tree to generate code. Just to prove to you that it's a tree, I wrote a little script to convert it into a graph. So this is a graph. I don't know how well that shows up over screen sharing, but this is the exact same information, but showed visually. And you can see like this tree kind of maps to this code, but it's a data structure. So we can take advantage of that. Data structures are easy to manipulate, whereas code, not so much. Strings, hard to work with. So as promised, we're going to write an import sorter. And this is going to mimic what's done in a library called isort. We're going to write a little function called sort imports, and it's going to take in a node of this tree. And we're going to extract all the imports, all the import froms. This is code being represented as nodes in a tree that we're then pulling out. And then we're going to get everything else. We're going to just sort them. These are lists of nodes. We can sort them. Just sort everything. And then we're just going to assign node.body back to the concatenation of everything that we extracted in the first place. And now what we can do with that node is, if we parse some Python code and we get a node, if we call sort imports on it, you can then call ast.unparse on that node. And ast.unparse will turn that abstract syntax tree back into source code for us. So we just did a whole lot of really complex code generation just by piggybacking on the compiler, on the parser that comes with Python. Super cool. Just so you know, ast.unparse is actually not in Python yet. That is coming in Python 3.9. So actually to write this code, I downloaded and compiled the developer alpha for Python 3.9 to be able to run this cool stuff. And it's actually a lot of fun. I highly recommend installing Python from source, because then if you have a question about Python, you can just go look at the source code, which is kind of fun. I don't know. I found it fun. I wanted to do a demo here, but I'm running out of time. But you know what? Screw it, because I already have it up. I know that's probably really small, but here's the import sorter. And I've got all these imports here, and they're out of order. And if I run this file on itself, we get the imports, but in order. A, C, C, F, S, D. I mean, it separated the import froms from the just straight imports. But you can also see that, you know, within an import from, everything is in order. Capitals first, and then lowercase. There's a bug here. I think that's a bug in the developer alpha version of Python that I downloaded. I'm just going to believe that it is because I couldn't figure it out. And so I think that's just because I'm ahead of the game. So I did try to fix that this morning, but I just straight ran out of time. So excuse the bug. That's all I got. So I'm going to go ahead and end the Zoom because I want the recording to upload. But are there any questions first? All right. Cool. All right. Well, I'll see you guys all next week for one of the best lectures. So next week, we're doing language-based metaprogramming, and a lot of people on their exit survey last year said it was their favorite lecture. And so I'm really looking forward to that. And I don't have to write the slides from scratch, so this will be a great week. So see you guys all next week.